Uh, Greetings of the day, dear students. I hope everybody doing well and good. And I also sincerely hope that your preparation is going on at a proper pace. In this session, Gate through questions, we will take up some good questions and important questions of Gate standard. Okay, I will be discussing here some important questions from analog circuits. So without wasting further time, let me proceed to the first question. And I want everyone to read the question once. It is a multiple choice question. In the circuit shown, MOSFETs have identical parameters, and those parameters are given here. Mu n COX W by L 2 milliampere per square volt. Threshold voltage is 1 volt, and channel length modulation parameter lambda is equal to 0. And we have to find out voltage Vx. So I want everyone to think about this question, and we will try to keep this session a bit interactive. So in this question, we have to obtain the value for voltage Vx, and these type of questions come quite frequently in the GATE paper. A question based on two MOSFETs connected in series. Okay, in this circuit we have two MOSFETs connected in series. Now when we solve such a question, we should first get an idea about operating region of the MOSFET. Okay, we should know whether MOSFET is in saturation region or in triode region. Now in this particular circuit, if you look at the two MOSFETs, their drain is shorted to gate. Okay, drain terminal shorted to gate terminal. Now whenever drain shorted to gate, then MOSFET will be in saturation region. I hope everybody knows it well from your preparation, that whenever drain shorted to gate, such MOSFET will be in saturation, because when drain is shorted to gate, that VDS and VGS become equal. Whenever drain and gate are shorted, you can say VDS is equal to VGS. Drain voltage will be equal to gate voltage. If VDS equal to VGS, then it will imply that VDS is definitely greater than VGS minus VT. Okay, VDS definitely greater than VGS minus VT. We can say it mathematically, because VDS equal to VGS, so VDS should be definitely greater than VGS minus VT. In this way, we can consider both MOSFETs in saturation region. Let me now indicate here current. MOSFETs are in series, their currents will be equal. Same current IDS will flow throughout. Okay, and also remember here, MOSFETs are identical, both are in saturation, and both have same current. Therefore, their VGS values will be equal. Okay, please remember, if two MOSFETs are identical, if both are in saturation, and if both have same current, here current will be same for both the MOSFETs. Under these three conditions, MOSFETs will be having same VGS. I can say VGS1 is equal to VGS2. So if I indicate here this as VGS, this will also be same VGS. Okay, I repeat once again, if two MOSFETs are identical, if both are in saturation, and if both have same current, then their VGS values will be equal. So that is why I have taken VGS as same here. Then we will apply KVL in this loop. Let us apply KVL. Okay, if I apply KVL like this, I will be getting 10 is equal to 1 into IDS plus VGS plus VGS plus 2 into IDS. You apply KVL in this way. Okay, use KVL in this loop. Let us apply that KVL here. When I use KVL in that loop, I will be getting 10 is equal to 1 into IDS plus VGS plus VGS plus 2 into IDS. Okay, I have applied KVL in this loop. 10 is equal to 1 into IDS, then plus VGS, and then plus VGS plus 2 into IDS. Now from this KVL, I can get relation between drain current and VGS. If you rearrange, you will be getting 10 is equal to, this will become 3 IDS plus 2 VGS. This you rearrange now, it will become IDS equal to 10 minus 2 VGS divided by 3. When I just rearrange it, I will get this relation between current and VGS. Let us call this as equation 1, and then we will apply the saturation equation of current. For a MOSFET which is in saturation, current is equal to mu n CoX divided by 2 into W by L into VGS minus VT whole square. Now in this equation, we will substitute drain current is equal to this much, and this parameter is given in the question. It is 2 milliampere per square volt and threshold voltage is 1 volt. So let us put all the values here. This will become 10 minus 2 VGS divided by 3 is equal to, this is like 2 divided by 2 into VGS minus 1 whole square. Now this equation you should bring into quadratic form. Okay, this equation we should bring into quadratic form, and then you solve this equation, you will be getting two values of VGS. Let me do that simplification here. 10 minus 2 VGS is equal to, this 2 and 2 it will cancel, it will be 3 into VGS square plus 1 minus 2 VGS. Now if you rearrange this expression, it will become 3 VGS square, and then minus 6 VGS plus 2 VGS, it will become minus 4 VGS. Then 3 minus 10, it will be minus 7 is equal to 0. And I hope everybody getting the same quadratic. Please solve this quadratic and tell me what are the values of VGS from this quadratic. If you solve this quadratic, you will be getting two roots. Okay, every quadratic has two roots. So please solve this quadratic and tell me what are the values. After solving, you will be getting two values of VGS. Let me just see whether I have got some values. Yes, Vivek has given me the value 2.33 volt and minus 1 volt. Yes, beta, perfect. 2.33 volt, 2.33 volt and minus 1 volt. These are the two values of VGS which we get. Now we should decide which VGS is correct. Now please remember, for a MOSFET, VGS should be greater than threshold voltage. Okay, that means VGS should be greater than 1 volt. VGS should be greater than threshold. So in this way, the correct VGS will be 2.33 volt. Okay, we should consider 2.33 and this we should ignore, because a MOSFET will conduct only when VGS greater than threshold voltage. So take VGS as 2.33, then calculate current. Current IDS is equal to 10 minus 2 VGS, 10 minus 2 into 2.33 divided by 3. Okay, I'm using this equation 1. Drain current is equal to this much. So from here you obtain drain current. You can also keep doing calculations and tell me your answers also. Drain current is equal to 1.78 milliampere. Yes, beta. I have got answers here from Kumar, Smita, Vivek, Ankita. Yes, beta. 1.78. 1.78 milliampere. Drain current is equal to 1.78 milliampere. Now, once we know VGS and this drain current, now we can find out how much is Vx. If you go back to the circuit here, we can tell from here Vx is equal to this VGS plus drop across 2K. Okay, if I travel from this node to ground, that Vx is equal to VGS plus 2 into IDS. I hope you are able to see it. From this circuit I can tell Vx is equal to VGS plus 2 into IDS. Okay, if you travel from this node to ground in this way, I will be getting Vx is equal to VGS plus 2 into IDS. Okay, it will be 2.33 plus 2 into 1.78. This you can calculate. I'm getting a value 5.89. 5.89 volt. And we can also calculate Vx the other way. It will be 10 minus 1 IDS minus VGS. It can be found in that way also. You can subtract from 10 volt, drop across 1K and this VGS. You will get same answer, 5.89. You can try in that way also. Vx is equal to 10 minus 1 into IDS minus VGS. You can try in this way also. Vx is equal to 10 volt minus drop across 1K minus VGS. You will get same answer, 5.89. So in this multiple choice question, the correct answer will be option B, 5.9 volt. We can take here answer as option B. I hope everybody understood this question. Yes, I have got here answers from Vivek, Kumar, Kapil, Ankita, Nikhil and Riya. Yes, beta, perfect. Treat this as an important model of question. Okay, if you refer previous GATE papers, almost every year a question is coming in which you will be having two MOSFETs connected in series. And when you solve this type of question, you should first decide operating region. And once you know operating region, you can apply appropriate current equation and get the desired answers. So this was our question number 1. The correct answer here is option B, 5.9 volt. Let's move to the next question. And this is also a multiple choice question. It is based on BJT circuit. So please read the question once and try to obtain answer. Here in the BJT circuit given, we have to tell the value of RB and corresponding operating region. Okay, the question is about the value of RB and the corresponding operating region. So it's a question based on operating region concept. Okay, in BJT we learn two methods for finding operating region, method 1 and method 2. There are multiple methods for finding operating region of a BJT. So this question is based on that operating region concept. Beta is given 50, VB 0.7 volt and VCE sat is 0.2 volt. Now what we will do is, we will try to solve this question through method number 1. I will indicate here this as IC, collector current. This will be IB. And here you can show VCE, collector to emitter voltage. And this is VBE. I will be using here the approach of first method, method 1 of finding operating region. Okay, we will first calculate IC sat. Let us assume the BJT in saturation, okay, and calculate IC sat, saturated collector current. Let me write here IC sat. It will be equal to 10 minus VCE sat divided by 3K. 10 minus VCE sat divided by 3K. That VCE sat given as 0.2. So 10 minus 0.2 divided by 3. This you need to find first. It is 9.8 divided by 3. Okay. It is 3.267. 3.267 milliampere. Now once we know IC sat, we can now find the minimum base current required to operate BJT in saturation, that we call as IB minimum. Minimum base current needed to operate BJT in saturation. It is IC sat divided by beta. 3.267 divided by 50. This you need to find out now. 3.267 divided by 50. I'm getting a value 65.34 into 10 power minus 3, or 0.06534 milliampere. Okay, this is minimum base current required to operate BJT in saturation. Now from the given circuit I will write IB. IB is equal to 5 minus VBE divided by RB. Okay, from the given circuit I'm trying to calculate IB. Base current is equal to 5 minus VBE divided by RB. That VBE given 0.7, so it will become 4.3 divided by RB. And now we will apply this condition that BJT will operate in saturation if IB greater than or equal to IB minimum. Let us apply that condition. BJT operates in saturation if IB greater than or equal to IB minimum. Okay, everybody knows this condition. If IB greater than or equal to IB minimum, then we say BJT is in saturation. Now you substitute here IB 4.3 divided by RB more than or equal to 0.06534. We are taking current in milliampere here, so resistor we get will be in kilo ohms. So from here I will be getting RB less than or equal to 65.8 kilo ohms. Okay, when RB less than or equal to this much, then BJT will be operating in saturation. I think that will help you in deciding which option is correct. Well, I have got here answers from Nikhil, then Arun, Shishir. Yes, Aditya, good evening, beta. Then Sanskar has given the answer. Priyag has given the answer. Vivek has given the answer. RB less than or equal to 65.8 kilo ohms, BJT will operate in saturation. Now you look at the options. For RB equal to 100K, BJT is in saturation. No, that will be wrong, because BJT is in saturation when RB less than 65.8. This we need to keep in mind. BJT is in saturation when RB less than 65.8 kilo ohms. So option A will be incorrect. Option B also false, because for RB equal to 40K, BJT will be in saturation. So option B is wrong. Option C, yes, this will be the answer. For RB equal to 60 kilo ohm, BJT is in saturation. That is perfectly correct. And option D, it will be of course false, because for RB equal to 50K, BJT will be in saturation only. So in this multiple choice question, the correct answer will be option C. This is also an important model of question which you can expect in the upcoming GATE paper. Okay, question based on operating region of a BJT, a very very important topic with respect to GATE paper. In this session I have selected some important type of questions, okay, which may appear in the upcoming GATE paper. So this was question number 2. Then let's move to the next question, and this is a question based on op amp, another hot favorite area for IIT professors to prepare a question for a GATE paper. Question based on op amp circuit. Please read this question once. Everybody read the question. In waveform generator shown, op amp and diodes are ideal, and we have to find time period of the output. The question is about calculating time period of the output. I will give you a bit of time. Give me some idea about what is this circuit. Look at the circuit and tell me this circuit will generate what type of output. Please give your answer as a comment. Okay, I have got here answers from some of you. It is a multi-vibrator circuit. Perfect. It is a multi-vibrator circuit. What type of output it will generate? That you tell me. What type of output waveform it is going to generate? Okay, I have got here answers. Square wave generator. It is a square wave generator. Yes, perfect beta. It is a square wave generator. This circuit is a square wave generator. We also call it astable multivibrator. Okay, astable multivibrator, square wave generator, or a free running oscillator. Okay, so once you look at the circuit, that idea should come in our mind. That circuit will give us what type of output. It is a standard circuit, astable multivibrator. It will provide square wave output, and that output will vary between plus 10 and minus 10. Output varies from plus 10 to minus 10. We will first of all calculate here threshold voltages, upper threshold, lower threshold. I hope everybody has idea about operation of astable multivibrator. When we deal with Schmidt trigger or astable multivibrator, we talk about threshold voltages, upper threshold and lower threshold. Let us calculate those threshold voltages first. Output is going to vary here between plus and minus 10. Output is a plus or minus 10 volt square wave. Plus or minus 10 volt square wave. Now when output is plus 10, this upper diode, if I call it as D1, D1 will be on. Okay, when output is plus 10, that D1 will be on, and when D1 is on, that 3K and 1K, they will form a divider, and I can calculate upper threshold. Let me write here. If V0 equal to plus 10, then diode D1 is on. Okay, D1 will be on. So if I calculate here upper threshold, it will be 10 into 1K divided by 1 plus 3. That is like 10 divided by 4. It will be 2.5 volt. Okay, 3K and 1K, they will form a divider, voltage divider. So by using voltage divider, I have calculated upper threshold, 10 into 1 divided by 3 plus 1. And when output equal to minus 10, that lower diode D2 becomes on. Okay, when output is minus 10, this D2 becomes on, and when D2 becomes on, 1K and 1K will form a voltage divider. Okay, output voltage will divide between 1K and 1K. So when we write lower threshold will be VLT equal to minus 10 into 1 by 1 plus 1, it will be minus 5 volt. So in this way, I have first calculated threshold voltages. Okay, when output is plus 10, that D1 is on, then output will divide between 3K and 1K. In that way, I have got upper threshold. And when output is minus 10, D2 will be on. And when D2 is on, 1K and 1K will form a divider. So in that way, I have calculated lower threshold equal to minus 5 volt. Okay, then let me plot here the waveform, output waveform. Output will be some square wave signal in this way. This is the expected output. Okay, it will vary between 10 volt and minus 10 volt. Then I will also indicate here threshold values 2.5 volt and minus 5 volt. Okay, these are the threshold voltages, upper threshold and lower threshold. And in this astable multivibrator, we have a RC network connected towards inverting terminal. Okay, there is an RC network connected towards inverting terminal, and everybody knows from the operation of astable multivibrator that when output is plus 10, this capacitor will charge through this resistor. Okay, and when output becomes minus 10, capacitor will discharge through this resistor. Okay, so in this astable multivibrator, whenever output is plus Vsat, capacitor will charge through the resistor, and when output becomes minus Vsat, capacitor will discharge through the resistor. And capacitor voltage varies between upper threshold and lower threshold. So let me draw here the waveform for capacitor voltage. Capacitor voltage will vary. When output is plus 10, capacitor voltage will increase exponentially like this, and when output is minus 10, capacitor voltage will decrease exponentially. These ideas you need to have from the operation of astable multivibrator, and I hope everybody is doing revision regularly. Okay, if you do thorough revision of the subject, you will be having this idea in your mind. Okay, when output plus Vsat, capacitor will charge, and when output minus Vsat, capacitor will discharge. Now this interval I will call it as T1, and this interval I will call it as T2. Okay, this is the interval where output is plus Vsat, and this is the interval where output is minus Vsat. Now we need to find out T1 and T2. To calculate time period, we should know T1 and T2. And to calculate this T1 and T2, we will be doing some transient analysis. Okay, everybody knows from networks the transient equation for capacitor. That equation I am going to use here. When I solve this question, I will be using this particular equation. Capacitor voltage is equal to V final plus V initial minus V final into e to the power minus T by R into C. Okay, that R into C is the time constant. Okay, that R into C is your time constant. You can calculate that R into C. It will be 500 ohm into 0.2 microfarad, 0.2 into 10 to the power minus 6. It will become 100 microseconds. Okay, time constant R into C is equal to 100 microseconds. In that transient equation, I will be using time constant equal to 100 microseconds. Fine. Now consider T1 interval. Let us consider T1 interval. Now in this T1 interval, if you look at capacitor waveform, the initial capacitor voltage is minus 5. In the T1 interval, initial capacitor voltage how much? Minus 5. Then what will be V final? In transient analysis, V final means capacitor voltage at t equal to infinity, and that will be equal to 10 volt. Let me write here V initial is minus 5 volt. and V final. Please remember, V final means capacitor voltage at t equal to infinity. At t equal to infinity, capacitor becomes open circuit. And when capacitor becomes open circuit, voltage across the capacitor will be equal to 10 volt. In transient analysis, please remember, V final implies voltage across capacitor at t equal to infinity. And at t equal to infinity, capacitor becomes open circuit. And if capacitor becomes open circuit here, then 10 volt will be there across capacitor. So V final is equal to plus 10. In the T1 interval, V final how much? Plus 10 volt. Now use these values and proceed with this transient equation. Vc is equal to, I will substitute V final 10 volt plus V initial को हमने यहाँ पर लिखा है -5, तो आप V initial की प्लेस में पुट करिए -5 minus 10 into e to the power minus t by rc. Okay, it will become Vc equal to 10 minus 15 into e to the power minus t by rc. Now we will apply this condition here. At t equal to t1, capacitor voltage becomes 2.5. Okay, at t equal to t1, capacitor voltage is how much? 2.5. Let me write this condition here. Vc equal to 2.5 volt at t equal to t1. Okay, at the end of t1 interval, capacitor voltage is how much? 2.5. This condition, you know, substitute here. You will be getting 2.5 is equal to 10 minus 15 into e to the power minus t1 by rc. Okay, हमने यहाँ पर t की प्लेस में लिखा है t1 और vc की प्लेस में हमने लिखा है 2.5. अब आप इसको सॉल्व करिए and try to find out t1. If you rearrange, you will get e power t1 by rc is equal to, इसको अगर आप rearrange करते हैं, it will become e power t1 by rc is equal to 2. Then take natural log on both the sides, take ln. I will get t1 equal to rc into ln2. rc into ln2. That r into c is 100 microsecond. उसको हमने यहाँ पर calculate किया था. r into c how much? 100 microsecond. That you can substitute here. It is 100 into ln2. ln2 will be like 0.69. If you find ln2, it is approximately 0.69. It will become 69 microseconds. 69 microseconds. So please remember, t1 is the interval where output is plus Vsat. Now we need to find out t2 also. Okay, in a similar way you should calculate t2 also. Let me just check whether some of you have given the answer. Yes, I have got answer from Harsh, 69.3 microseconds. Yes, but 69.3 microseconds. 69.3 microseconds. अगर आप इसको और accurately find करते हैं, it will be 69.3 microseconds. This is like 0.693, I think. ln2 is 0.693. So this will become 69.3 microsecond. In a similar way, you should calculate now T2. We will now consider T2 interval. In the T2 interval, initial capacitor voltage will be 2.5 and final capacitor voltage will be minus 10. Okay, let me write it here. Consider T2 interval. In the T2 interval, initial capacitor voltage is equal to 2.5 volt and final capacitor voltage, it will be minus 10. Okay, this we have observed from this waveform. V initial will be 2.5 and V final will be minus 10. V final means voltage across capacitor at t equal to infinity. That will be minus 10 volt. Then use your transient equation Vc equal to V final plus V initial minus V final, minus into minus, it will become plus 10 into e to the power minus T by RC. So this becomes the equation for capacitor voltage in the interval T2. Now we will apply this condition. At the end of T2 interval, capacitor voltage becomes how much? Minus 5. At the end of T2 interval, capacitor voltage is becoming minus 5. So we will now substitute Vc equal to minus 5 and T equal to T2. Put Vc equal to minus 5 and T equal to T2. This you can substitute here. Minus 5 is equal to minus 10 plus 12.5 into e to the power minus T2 by RC. This you rearrange, and from here I will be getting e power T2 upon RC is equal to 2.5. Then take natural log on both the sides. You will be getting T2 equal to RC into ln 2.5. That RC is 100 into ln 2.5. तो आप यहाँ से T2 फाइंड करिए. ln 2.5 into 100. It is coming out as 91.63. 91.63 microseconds. Okay, this is your T2. Now we can tell time period. Time period is T1 plus T2. T1 को हमने इससे पहले कैलकुलेट किया था. It was 69.3 microseconds plus T2 91.63 microseconds. 91.63 plus 69.3. It is coming out as 160.9 microseconds. In this square wave generator, output waveform has a time period 160.9 microseconds. Okay, now look at the options. I think the nearest option will be option A, 161 microsecond. We got answer 160.9 microsecond. The nearest option, it will be 161 microsecond. So for this question, the correct answer will be option A. Let me just check your comments. Okay. Aftab, Shishir, then Harsha, Ankita, Kumar, Venkatesh, Riya, yes, and Kush Kumar. Yes, beta, perfectly correct. This is an important circuit from gate point of view. Positive feedback op-amp circuits. In positive feedback op-amp circuits, we come across Schmitt trigger, astable multivibrator, and triangular waveform generator. These are important circuits from gate point of view. Okay, I'm expecting a question in the upcoming gate paper from positive feedback applications of op-amp. The question can be from Schmitt trigger, it can be from this square wave generator, astable multivibrator, or it can be from triangular waveform generator. Please prepare these topics thoroughly. Okay, so this was our third question in astable multivibrator. Let's move ahead. It required a bit of transient analysis. Okay, you need to have idea of transient analysis. This equation is important. Okay, if you know this equation and if you know how to write initial voltage, final voltage, then you can easily solve this type of question. It's a bit lengthy, but it can be solved. Okay, let's move to the next question. Now please have a look at this. It is relatively a simpler one, a question based on diode circuit. Please read the question and give your answers. Please read the question once. In the circuit shown, diodes are ideal. Okay, and input is 10 sin omega t volt. We have to find maximum and minimum values of output. We have to calculate here maximum and minimum values of output. What is maximum output and what is minimum output? There are two diodes here. Let us name them D1 and D2. This question looks like a two-level clipper. If you have studied clippers in the diode topic, then you should be knowing this circuit. It is similar to a two-level clipper, two-level shunt clipper. Now when we analyze clippers, we initially consider diodes as off. So initially we will assume here that both diodes are off. If both the diodes are off, then input will appear here. Okay, input will appear at this node and input also appears at this node. That input you compare with plus 4 volt and you also compare input with minus 5. This should be taken as minus 5 because it has a negative terminal up and positive terminal down. This voltage you take as minus 5 and this you take as plus 4. We have to compare here input with plus 4 and we have to compare input with minus 5. If input becomes greater than plus 4, then D1 becomes on. Okay, and other diode D2 will be off. Let me write that here. If Vi greater than 4 volt, then D1 on and D2 will be off. And we can redraw the circuit in this way. The D1 I will replace with a short circuit. This is 1K and this also 1K. Okay, and this is your V0. When input is greater than plus 4, D1 becomes on and other diode D2 will be off. Let us forget about D2. Just replace D1 with a short circuit. Now we can calculate here V0 with the help of superposition formula. You have 1K and 1K in series. So it is like R1, R2 in series. This is your V1 and V2. And you know how to calculate voltage at this node. We can apply superposition formula. Using superposition, V0 is equal to Vi into 4, sorry, Vi into 1, Vi into 1 plus 4 into 1 by 1 plus 1. I hope everybody remembers superposition formula. V1 into R2 plus V2 into R1 by R1 plus R2. I have applied that superposition formula here. V0 will be this much. It is like Vi plus 4 divided by 2. Now this is the output when input is greater than 4 volt. Now when I say input greater than 4, it means input can become 5 volt, 6 volt, 7 volt, 8 volt, 9 volt up to 10. Input is given as 10 sin omega t. So input can increase up to 10. And when that input becomes 10, output will become maximum. Okay, we have to find here maximum output and minimum output. So input, when it reaches maximum value 10 volt, output will become maximum. So max V0 is equal to 10 plus 4 divided by 2. It will be like 7 volt. Maximum V0 how much? 7 volt. When input becomes maximum, output also becomes maximum. Maximum output is 7 volt. I think if you look at the options here, that is enough to tell the correct option, because only one option has maximum output 7 volt. So in that way my answer should be option B. So sometimes in the GATE paper you don't need to do complete solution. Like in this problem, if I decide maximum output, that is enough to tell me the correct option. Only option B has maximum output as 7, so my answer will be option B. And you can find minimum output also, but in the exam you don't need to calculate that minimum output minus 9. Just calculate maximum output 7 volt. Only one option has 7 volt, so my answer will be option B. And in case you want to learn how we calculate minimum output, then it will be done in this way. To know minimum output, you compare input with minus 5. If input becomes less than minus 5, then D2 becomes on. Okay, if input is less than minus 5, then D2 will become on. Let me just write here. If Vi less than -5, then D2 becomes on, whereas D1 it will be off. And we can redraw circuit like this. We replace here D2 with a short circuit, okay. This will be the equivalent circuit, D2 replaced by short circuit. And once again I can calculate V0 with the help of superposition approach. It will be Vi into 4 plus -5 into 1 by 1 plus 4. V0 is equal to 4 Vi plus -5 into 1 by 1 plus 4. So in this way I will be getting V0 equal to 4 Vi minus 5 divided by 5. Okay, I have applied once again superposition formula. Vi into 4 plus -5 into 1 by 1 plus 4. Now this is the output when input is less than -5. Input less than -5 means input can become -6, -7, -8, -9, -10. When input becomes -10, output will become minimum. Okay, remember this is the output when input less than -5. When I say input less than -5, it means input equal to -6, -7, -8, -9, -10. तो आप यहाँ पर Vi equal to -10 put करिए, you will get minimum output. Minimum output equal to 4 into -10 minus 5 divided by 5. It will give you -9 volt. Okay, now in the exam to decide which option is correct, you don't need to do all this calculation. Just get maximum V0, you can easily decide which option is correct. This I have done only to give you the clarity that how we calculate minimum output. So in this question maximum output 7 volt and minimum output is -9. Okay, I have got here answer from Sanskar Sharma, then Kumar, Venkatesh and Kush Kumar. Yes, better 7 and -9. 7 and -9. The correct answer is option B. And I think even Nikhil has given the answer. Nikhil, yes, but option B. Then Parrot 306, answer is option B, perfectly correct. So this is also an important circuit from gate point of view, clipper. You can expect a question based on diode clippers in the gate paper. Now each question in this session I have selected from important topic. Okay, so this is a question from clipper, so please prepare clippers properly. You can expect a question maybe for 1 mark or 2 mark in the gate paper based on clipper concept. Let's move ahead. This is another multiple choice question which is based on a BJT amplifier. This question is about a BJT amplifier, a really good quality question which can come in the gate maybe for 2 marks. Okay, transistors in amplifier shown have beta equal to 100, GM 50 millimho and early voltage infinite, VA equal to infinite, and we have to tell what will be voltage gain magnitude. We have to obtain V0 upon Vi magnitude. So please think about this question. It is a good quality question. We have to tell here voltage gain V0 upon Vi, and this BJT parameters they are given in the question, beta equal to 100, GM 50 millimho and VA infinite. Now when we calculate voltage gain, in our voltage gain calculation we have to disable all DC sources. Please remember, voltage gain calculation comes under small signal AC analysis. So when we perform small signal AC analysis, we have to disable all DC sources. तो जब हम इस क्वेश्चन को सॉल्व करेंगे we will disable all DC sources. This VCC node it will be grounded. Here also VCC node it will be grounded. And IDC it is a DC current source. It will be open circuited. DC sources are disabled. DC voltage source replaced by short circuit. DC current source replaced by open circuit in small signal AC analysis. And V bias is also a DC source. It will be replaced by short circuit. Okay, so when we calculate our voltage gain, we have to make these changes. Fine, and let me name this transistor as Q1 and this as Q2. And you can observe input is given at the base of Q1 and output taken from the collector of Q1. So we can say Q1 is a common emitter amplifier. Q1 is a common emitter amplifier. Input is given at the base and output taken from collector. And then that circuit can be redrawn in this way. हम circuit को redraw कर लेंगे इस तरह से. This node is grounded. This is your 3K resistor. Output taken from here. This is Q1. Input applied at the base of Q1. And then this emitter of Q1 is connected to emitter of Q2. तो मैं यहाँ पर Q2 को भी दिखा देता हूँ इस तरह से. This is your Q2. Okay. Emitter of Q2 connected to the emitter of Q1. Then collector of Q2 is grounded, and between base and ground you have 8K. So you can say 8K is between base and collector. Collector is grounded here, and 8K is between base and ground. Ground and collector they are like same. तो हम ये कह सकते हैं कि 8K is between base and collector. You can show here 8K resistor like this. Some R is equal to 8K. Let us call it as R. Okay, that 8K is between base and ground, and collector is grounded. So in this way, I have redrawn the given amplifier. Okay, Q1 is a common emitter amplifier, no doubt. Q1 it is a common emitter amplifier, and Q2 can be shown in this way. Emitter of Q2 connected to emitter of Q1, and 8K is between base and ground, and collector of Q2 grounded. I hope you are able to follow. Collector of Q2 grounded, and between base and ground we have 8K. Now we should find out equivalent resistance of Q2. This Q2 will be offering some resistance that I call as R equivalent. I will now calculate equivalent resistance of Q2. Q2 is a BJT here in which 8K resistor is present between collector and base. So I will now find out equivalent resistance of Q2, that is nothing but resistance between emitter and collector, or resistance between collector and emitter. So to find out this R equivalent, I am going to replace Q2 with pi model. Let us replace Q2 with pi model. It's a very good question. Replace Q2 with pi model. This is your R pi. This you can indicate as beta IB. Now between base and collector you have to draw that R equal to 8K. R equal to 8K. And our aim is to find R equivalent. That R equivalent is nothing but resistance between emitter and collector. That R equivalent is resistance seen between emitter and collector. So between emitter and collector you apply a test voltage. You can apply here some test voltage like this, Vx, and assume here current Ix, and find out Vx upon Ix. That Vx upon Ix will give you R equivalent. current in this branch, it will be like IB. Okay, current through this R pi is IB, and current through 8K is also IB. This can also be taken as IB. That IB will flow through this 8K and then into R pi. Now first apply KCL. If I apply KCL, I will get Ix equal to beta IB plus IB, or it is like IB into 1 plus beta. Is that okay? I have applied KCL here. Ix equal to beta IB plus IB, so it become like this. Then apply KVL. If you apply KVL, use KVL in this loop. KVL like this. Okay, apply KVL in this loop. You will get Vx equal to IB into R plus IB into R pi. Okay, I have applied KVL here. Vx is equal to IB into R plus IB into R pi. Then divide Vx upon Ix. Vx divided by Ix, that will give us R equivalent. And if you divide Vx upon Ix, that IB it will cancel out, and I will be getting R equivalent equal to R plus R pi divided by 1 plus beta. So in this numerical, Q2 is offering an equivalent resistance this much, R plus R pi divided by 1 plus beta. Now you substitute R equal to 8K, R pi, we can tell R pi from the data. We know here beta and GM. If you know beta and GM, then R pi will be beta upon GM. Everybody knows it from pi model topic, BJT amplifiers. R pi is equal to beta upon GM. So it will be 2 kilo ohms. Okay, 100 divided by 50 milli, it will become 2 kilo ohms. So take R pi equal to 2 kilo ohms. R pi 2 kilo ohms divided by 101. It will be like approximately 0.1 kilo ohms. Approximately 0.1 kilo ohms. R equivalent of Q2 is 0.1 kilo ohm. Now we can redraw the given amplifier in this way. That given amplifier, it can be redrawn like this. We replace Q2 with R equivalent 0.1 kilo ohm. This is your Vi. Here is V0. That given amplifier is redrawn in this way. Q2 is replaced with R equivalent. Now please observe, this is nothing but a common emitter amplifier with unbypassed emitter resistance. We can now call Q1 as a CE amplifier, common emitter amplifier without bypass capacitor. It is a common emitter amplifier without bypass capacitor, and it's a very standard amplifier, a very important amplifier, and everybody knows voltage gain formula for this type of amplifier. If you write voltage gain, it will be minus GM into RC divided by 1 plus GM into RE. I hope everybody remembers this formula. Common emitter amplifier without bypass capacitor. Voltage gain will be given by this expression. Now you substitute here GM 50 milli, that RC it will be 3 kilo ohms divided by 1 plus 50 into 0.1. Okay, that milli into kilo it will cancel out. We are taking transconductance in milli and resistor in kilo ohm. Milli into kilo it will cancel out. Now please find out this voltage gain. I have got some answers here. Bashir Ahmed has given the answer, and Venkatesh has given the answer. Kusum has given the answer. Kush Kumar, yes beta, minus 25. It will be approximately, it is like minus 150 divided by 6. it will be minus 25, minus 25. So in this amplifier, voltage gain is minus 25. Now if you look at the options, we have to tell magnitude of the gain. Magnitude will be 25. Magnitude of the voltage gain, it will be how much? 25. Okay, we have got answer as minus 25. That minus sign only indicates phase shift of 180. V0 and Vi, they are 180 out of phase. But the question is about magnitude of the gain. Magnitude will be 25. So in this question, the correct answer is option C. Answer will be option C. It was a good quality question. Okay, you can expect these type of questions also in the GATE paper. You have to replace Q2 with equivalent resistance. Once you replace Q2 with equivalent resistance, then it becomes easy to calculate voltage gain. I hope everybody understood this. So please practice this concept also. To replace transistor with equivalent resistance. Sometimes transistor will be replaced with equivalent resistance, or in MOSFET amplifiers we replace MOSFET with an equivalent resistance. Okay, it is an important type of question. Question based on amplifiers in which transistor is replaced with some equivalent resistance. Let's move to the next question. Well, another a good quality question based on MOSFET amplifier. In the amplifier shown, MOSFETs have following parameters, and some hint is given here. Neglecting channel length modulation effect in DC analysis, what will be voltage gain magnitude? It is a numerical answer type question. We have to obtain voltage gain magnitude. Please think about this question. Now if you look at the circuit here, in the given circuit, that M1 MOSFET M1 will act like an amplifier here. Okay, input is applied at the source terminal, and output taken from drain. Okay, input is connected to the source terminal and output taken from drain. So in that way, M1 is nothing but common gate amplifier. MOSFET M1, it is a n channel MOSFET. मैं यहाँ पे लिख देता हूँ NMOS M1. It will act as a common gate amplifier. Common gate amplifier. Okay, MOSFET M1 will be acting as a common gate amplifier, and M1 is a n channel MOSFET, whereas remaining MOSFETs, they are all p channel MOSFETs. Okay, this M2, M3, M4, all these are p channel MOSFETs, and this M2, M3, M4, they form current mirror. So in this problem, current mirror is used as a load. Okay, for M1, this current mirror will act as a load. So when we find voltage gain, we will have to replace current mirror with equivalent resistance. That equivalent resistance of the current mirror will act as a load for M1. And initially we will do some DC analysis. Okay, because to calculate voltage gain, we should know transconductance of M1. Okay, to calculate voltage gain, we need to know transconductance of M1, and to calculate that transconductance of M1, we need to know drain current of M1. So let us first obtain DC drain current. That DC drain current I will be finding by using current mirror approach. पहले हम इस branch का current find कर लेंगे, and whatever current flows here, same current will flow here. Okay, let me call this current as some ISD, source to drain current of the PMOS. This you can show as VSG3. This can be taken as VS G4. Now please observe here, these MOSFETs M3, M4, they are like identical. M3, M4, they are identical. Both are in saturation. Drain shorted to gate. Drain shorted to gate. So M3, M4, they are identical. They are in saturation and they have same current. Therefore, Vs G3 should be equal to Vs G4. I have told already in one of the question earlier, if two MOSFETs are identical, if both are in saturation and if both have same current, then their VGS or VSG will be same. So we can say Vs G3 is equal to Vs G4 and Vs G3 plus Vs G4 it will be equal to 5 volt. अगर आप KVL अप्लाई करते हैं Vs G3 plus Vs G4 is equal to how much? 5 volt. तो मैं यहाँ पे लिख देता हूँ Vs G3 plus Vs G4 is equal to 5 volt. This is nothing but KVL. But Vs G3 is equal to Vs G4. Okay, so in this way you can say Vs G3 it will be how much? 2.5 volt. Vs G3, Vs G4 they will be same. So each voltage should be how much? 2.5. Now calculate current ISD. It will be mu P into COX by 2 into W by L into VSG minus mod VT whole square. This parameter will be 30 divided by 2 and W by L for PMOS. If you look at the question, the W by L ratio for PMOS is given as 10. Okay, you can substitute that. W by L is 10 into 2.5 minus 1 whole square. तो आप यहाँ से करंट की वैल्यू फाइंड करिए बेटा. हाउ मच इज करंट? Let us calculate current here. I'm getting a current value 337.5 microampere. 337.5 microampere. Okay. Now use property of current mirror. Whatever current flows here, same current should flow here. So in this way, drain current of M1 should be equal to how much? Same current like this. इस करंट को हमने फाइंड किया था 337.5 माइक्रो. सेम करंट विल फ्लो हियर. ओके, वी आर यूजिंग प्रॉपर्टी ऑफ करंट मिरर. फॉर M1 MOSFET M1 drain current is equal to 337.5 microampere. We have used property of the current mirror beta. Then calculate GM1 transconductance. You know how to calculate transconductance? Under root 2 into mu n COX into W by L into drain current. Substitute here all the values. 2 into mu n COX 60 micro, W by L for NMOS is 5 into current 337.5. Okay, that mu n into COX is 60 microampere per square volt. Then W by L for NMOS is 5 and current equal to 337.5. Now from here calculate GM1. GM1. I'm getting it as 450 micromo. 450 micromo. This is transconductance of M1. Transconductance of M1. And now if you look at the circuit here, that M1 is acting as a common gate amplifier, no doubt, and this current mirror, it will be replaced with an equivalent resistance. And you know how much is equivalent resistance for a current mirror? It will be equal to RDS of M2. Everybody knows it from active load topic. active load in MOSFET amplifiers. When we use current mirror as a active load, then equivalent resistance of the current mirror will be RDS of this M2. Okay, and that RDS given in the question 1 mega ohm. Equivalent resistance for the current mirror will be RDS2. So I'm going to replace entire current mirror with this equivalent resistance. In the calculation of voltage gain in small signal AC analysis, we use this concept of equivalent resistance. And this 5 volt node, it will be like grounded. So this RDS2, it will be between drain and ground. And V bias node, it will be like grounded. In our AC analysis, V bias node will be grounded. So given amplifier can be redrawn in this way. हम given amplifier को इस तरह से redraw कर लेंगे. This is your VI. This is V0. And that current mirror replaced by equivalent resistance RDS2. Now replace M1 with small signal model. You know the small signal model for a MOSFET? It will be having these two elements in parallel. This is GM1 into VGS. This is RDS1. I'm replacing here M1 with small signal model. Then you connect remaining components between gate and ground. Gate is like grounded, gate grounded. फिर हम यहाँ पर दिखा देंगे input source VI. This is VI. And between drain and ground, we have to show RDS2 like this. And this is V0. Drain to ground, you have RDS2. So in this way, given amplifier is redrawn. We have replaced M1 with small signal model. And from this small signal model, we have to obtain voltage gain. Yes, Shishir, Ankita, then Nikhil, Kumar, thank you beta, you are with me. Bashir, yes, GM1 450 micromo. Nikhil has given voltage gain value also. ठीक है बेटा, हम check कर लेंगे how much it will be. Now from this circuit you have to obtain voltage gain. तो पहले आप यहाँ पर एक KVL अप्लाई करिए. यूज KVL in this loop. अगर आप यहाँ पर KVL अप्लाई करते हैं, you will get VGS plus VI equal to 0, or we get here VGS equal to minus VI. Okay, simple KVL here, VGS plus VI equal to 0. Then we will apply KCL at the drain terminal. Let us apply now KCL at the drain. KCL at drain. You can indicate all these currents flowing like this. Okay, sum of these three currents is equal to 0. I'm going to use KCL at the drain terminal. Sum of these three currents is equal to 0. In this amplifier analysis, you have to be very, very good at network analysis. Amplifier analysis is all about network analysis. Okay, तो पहले हमने एक KVL अप्लाई किया यहाँ पर. Then I'm applying a KCL. Sum of these three currents is equal to 0. GM1 into VGS plus what will be current in RDS1. अगर आप current in RDS1 लिखते हैं, it will be V0 minus VI divided by RDS1. V0 minus VI divided by RDS1. Okay, this node is at V0 and this node is at VI. तो अगर आप करंट थ्रू RDS1 लिखते हैं, it will be V0 minus VI divided by RDS1. And what will be current through RDS2? It will be V0 divided by RDS2. V0 divided by RDS2 is equal to 0. And now you can put VGS as minus VI. It will become minus GM1 into VI plus V naught upon RDS1 minus Vi upon RDS1 plus V naught upon RDS2 is equal to 0. Okay, VGS I have replaced with minus Vi and this term I have separated. इसको आप थोड़ा सा rearrange कर लो बेटा, please rearrange it. You will get V naught upon Vi from here. If you rearrange, V naught upon Vi will be GM1 plus 1 by RDS1 divided by 1 upon RDS1 plus 1 upon RDS2. Okay, that voltage gain can be written in this form. Now you substitute transconductance in micromho and RDS in mega ohm. That micro and mega it will cancel out. GM1 हमें पता है 450 micromho. Okay, and 1 by RDS1 it will become 1 itself divided by 1 plus 1. It will be like how much? 225.5. Okay, अगर आप voltage gain find करते हैं it will be 225.5. I hope everybody is getting the same answer. $225.5. It's a numerical answer type question. So the correct answer will be 225.5. Voltage gain. In this numerical answer type question, voltage gain magnitude is 225.5. So this was a question based on common gate amplifier. A common gate amplifier having current mirror as a load. I hope everybody understood it. Then we will proceed to the next question, and let me just quickly revise this solution once again. We first did here DC analysis. Through DC analysis we calculated drain current. From that drain current we calculated GM1. Okay, then current mirror we have replaced with equivalent resistance, then M1 replaced with small signal model, and from there we got our voltage gain equal to 225.5. Let us move to the next question. This is also a numerical answer type question. Please have a look and try to solve it. It is relatively a simpler one. Okay, just have a look at the question. In circuit shown, op amp is ideal, and you have to find out magnitude of transfer impedance V naught upon Is in mega ohm. Okay, we have to calculate the ratio V naught upon Is, output voltage divided by input current. That ratio will be called transfer impedance, or we can call it trans impedance, trans resistance. We can call it trans resistance gain also. Output voltage divided by input current, V naught upon Is. It can be called transfer impedance, transfer resistance, or trans resistance gain. So question can be asked in many ways. Calculate trans resistance gain for the op amp circuit shown, calculate transfer impedance for the circuit shown. This is basically an I to V converter. It is a current to voltage converter. We call it I to V converter or a trans resistance amplifier. Input is a current, output is voltage. So for this I to V converter we have to obtain V naught upon Is. Now these are like op amp circuits having negative feedback, and the approach to solve op amp circuits having negative feedback, you have to use virtual short circuit property and then KCL. Okay, it's a op amp circuit having negative feedback. You can call this node as A and then use virtual short circuit property. If I apply virtual short circuit, then VA equal to 0. Okay, node A is virtually grounded. Whenever we solve question on negative feedback op-amp circuit, we assume op-amp in linear region and thereby we apply virtual short circuit property. VA equal to 0. You can call this node as B and then indicate some currents. Let us call this as I1, this current as I2 and this current as I3. You can indicate these currents in any direction. The direction of the currents does not matter. Ultimately answer will be same. Okay, here I have shown currents in this way. First I will apply KCL at A. KCL at node A. I will be getting IS equal to I1. IS equal to I1 or IS equal to, that I1 can be written as 0 minus VB divided by 45. 0 minus VB divided by 45. So from here I will be getting VB minus 45 into IS. Let us call it as equation 1. Then use KCL at node B. These negative feedback op-amp circuits are very easy to analyze. Use virtual short circuit property and then start using KCL. First I have applied KCL at A. I got this relation. Then use KCL at node B. KCL at B. I will be getting I1 plus I2 plus I3 is equal to 0. Now in place of I1 I can put IS. IS equal to I1 here. So in place of I1 you just put IS plus I2. What will be I2 here? I2 will be V0 minus VB divided by 55.5. V0 minus VB divided by 55.5 plus I3. I3 will be 0 minus VB divided by 5. This resistor is 5K. Okay, so I3 will be 0 minus VB divided by 5 is equal to 0. अब आप इसको सॉल्व करिए बेटा. Keep this as it is plus V0. In place of VB you can substitute minus 45 into IS. So minus into minus it will become plus 45 IS divided by 55.5. This will become plus 45 IS divided by 5. It will become 9 IS. Okay, 45 IS divided by 5, it will become 9 IS. That 9 IS plus IS, it will become 10 IS. इसको आप और simplify कर लो बेटा. Everybody knows how to carry out simplification. तो आप इसको simplify करिए. It will become 555 IS plus V0 plus 45 IS is equal to 0. Or if you rearrange, you will get V0 upon IS is equal to minus 600K. Minus 600K or minus 0.6 mega ohm. We want magnitude of this gain. So magnitude will be 0.6 mega ohm. Okay, this is the question. Magnitude of transfer impedance in mega ohm. It is a numerical answer type question. You have to be careful in numerical answer type questions. You should get the answer in whatever unit they mention in the question. Here in the question they mentioned the unit mega ohm. So we have calculated transfer impedance in mega ohm. Answer is 0.6 mega ohm. Yes, Venkatesh, Shruti, Spider, Kush, Bashir, Kusum, Ankita, Ria and Nikhil. Yes beta, 0.6 mega ohm. That is the answer. 0.6 mega ohm. So you can expect a question based on negative feedback op-amp application also. So please remember, when we solve these type of questions on negative feedback op-amp circuits, we apply virtual short circuit property. And that virtual short circuit can become invalid also under some special cases. You know it very well. Virtual short circuit becomes invalid when op amp has smaller gain, and virtual short circuit becomes invalid when output is saturated. So under those two cases we should not use virtual short. Okay, if op amp has smaller open loop gain, virtual short invalid. If output is saturated, then also virtual short invalid. And all remaining negative feedback op amp circuits, they will be analyzed with the help of virtual short circuit. Okay, in this session I have taken one question on positive feedback, that astable multivibrator, and this was a question based on negative feedback op amp circuit. So when a question comes in the op amp, it can be from anywhere. It can be from positive feedback applications of op amp or negative feedback application of op amp. Please prepare op amp topic thoroughly. Okay, an important area. Let's move ahead to the next question. It's a question based on again diode, a numerical answer type question based on diode circuit. Please read the question and try to get the answer. In circuit shown, diodes are ideal if input is triangular waveform as shown below. Then the average value of V0 in volt, we have to calculate average value of this V0 in volt, and input is given as a triangular waveform. Input is a triangular waveform. It varies between +6 and -6. Okay, and this interval is half time period. This interval is also half time period. Okay, positive cycle is for half time period and negative cycle also for half time period. It's a triangular waveform. A triangular waveform. Let us solve this question. Now when input is positive, that D1 will be on and D2 will be off. Okay, let's proceed in this way. If input is positive, then D1 on and other diode D2 will be off. Okay, then we can redraw the circuit in this way. हम सर्किट को इस तरह से रीड्रॉ कर लेंगे. Okay, with D1 in on condition, that Vi will appear here across this 2K. Okay, D1 is on, so Vi will appear here across this 2K, this 2K and 1K 1K. And this is your V0. That input is present here, Vi present here, and you can easily tell V0 with the help of voltage divider. V0 will be Vi by 2. This Vi which we see here, that Vi will divide between 1K and 1K. Okay, this Vi will divide between 1K and 1K. तो अगर आप V0 लिखते हैं, it will be like Vi into 1 by 1 plus 1, it is Vi by 2. So in the positive cycle, that V0 is how much? Vi by 2. Then let us consider negative cycle. If input is negative, okay, now D2 becomes on, D2 on and D1 will be off. That D2 will become on. With D2 becoming on, input will be seen across this 1K. Okay, when D2 becomes on, that input will appear across this 1K. तो हम सर्किट को इस तरह से रीड्रॉ कर लेंगे. Input will be visible here. This is 1K, 1K and 2K, and this is V0. Fine. I hope everybody understood this part. When D2 becomes on, okay, that input will appear across this 1K. With D2 becoming on, input will appear across this 1K. तो उस input को मैंने यहाँ पर दिखा दिया है. नाउ वी नॉट, हम वी नॉट को इस तरह से फाइंड करेंगे, इसको हम लिख देंगे नोड ए, दिस वी विल कॉल एज नोड बी. ओके, दैट वी नॉट इज वी ए माइनस वी बी. वी नॉट इज इक्वल टू वी ए माइनस वी बी. If you calculate VA through voltage divider, it will be VI into 2 by 1 plus 2, VI into 2 by 1 plus 2 minus VB. VB is same as VI. So it will be like 2 VI by 3 minus VI. I will get minus VI by 3. Minus VI by 3. Okay. I hope everybody understood it. I have calculated V naught as VA minus VB. You have to pay attention to the polarity. V naught is shown with this type of polarity, plus here and minus here. तो जब आप V naught लिखेंगे, it will be VA minus VB. VA will be VI into 2 by 1 plus 2 voltage divider, 2 VI by 3, and VB is same as VI. 2 VI by 3 minus VI, it will become minus VI by 3. Minus VI by 3. So in this question, when input is positive, output will be VI by 2, and when your input becomes negative, then V naught is how much? Minus VI by 3. Minus VI by 3. तो अब हम यहाँ पर आउटपुट को प्लॉट कर लेते हैं बेटा. Let me draw the output. This is like t equal to 0, t equal to t naught by 2, and this is t equal to t naught. Okay, from 0 to t naught by 2, output will be Vi by 2. Vi by 2 means it will increase up to 3 volt. Okay, this is like Vi by 2, and in this interval output is minus Vi by 3. Minus Vi by 3 means output will become positive only. नेगेटिव इंटू नेगेटिव विल बिकम पॉजिटिव. तो अगर आप इस इंटरवल के लिए आउटपुट प्लॉट करते हैं, इट विल बी लाइक दिस. दिस विल बी 2 वोल्ट. ओके, आई होप एवरीबडी अंडरस्टूड. इन दिस इंटरवल इनपुट हैज ए नेगेटिव साइकिल, बट इन दिस इंटरवल आउटपुट इज minus Vi by 3. So minus into minus, it will become plus. This is like minus Vi by 3. And we have to find out now average. Average V naught. You know how to calculate average? It will be area divided by time period. Area divided by time period. Okay. When I say area, I mean this area. Okay. This is nothing but triangle. You know how to write area of a triangle. 1 by 2 into height into base. 1 by 2 into height into base. तो जब आप area लिखेंगे, it will be like this. 1 by 2 into. For this portion, what will be the height? Height will be 3. Okay. And what will be base? Base will be T naught by 2. 3 into T naught by 2. Plus. What about this portion? For this portion, height will be 2 volt. And base is again T naught by 2. So 1 by 2 into height into base. Whole divided by T naught. ओके तो आप इस तरह से एवरेज फाइंड कर लो बेटा. Please find out this average. How much is this average? It will become, this is like 3 by 2. 3 by 2 will be how much? 3 by 2. 3 by 2 will be 1.5. Sorry, 3 by 4 it will become. This is like 3 by 4, 0.75. 0.75 plus this is like 0.5. So answer is 1.25 volt. Answer is 1.25 volt. Yes, I have got answers from like almost all of you. Kumar, Nikhil, Shruti, Arun, Shivam, Kush, Venkatesh, Ankita, Shishir, Dinesh, Kusum and Bashir. Yes beta, answer is 1.25. So this, another important type of question. You may be given some diode circuit and you will be asked to find average output. Now when you are finding that average output, you should first analyze the circuit. Okay, what happens when input is positive, what happens when input is negative. Okay, for the positive cycle what is output, for negative cycle what is output. Once you decide that, you can sketch the output waveform. Here output is like a triangular wave, so we can tell area of the triangle half into height into base. Okay, and average is always area divided by time period. Average value or DC value, it is nothing but area divided by time period. So in this way we get our average output 1.25 volt. Yes, Aftab, 1.25 volt is the correct answer beta. So this was a numerical answer type question. Let us now proceed to, I will take up next question here. This is another important model of question that can appear in the GATE. Please go through it. It's a relatively easy question. A question based on Zener diode regulator. It is a multiple select question, MSQ, okay, where more than one option can be correct. So please read the question carefully and try to tell me what could be the correct options here. It is a multiple select question. So everybody go through the question. In regulator shown, Zener diode has breakdown voltage 8 volt, knee current 2 milliampere. If supply varies from 12 volt to 18 volt, then which of the following is correct for proper operation of circuit? So please try to solve this question. It's a Zener regulator. I think without a doubt option D has to be correct here. Zener diode should be in breakdown. That has to be a correct option. Option D is correct, no doubt. Then also look at option ABC. It is a multiple select question. More than one option can be correct here. Option D is 100% correct. Apart from that, other options can also be correct. Let us decide that. So first of all, you indicate here current. This as IS. This voltage is VZ, breakdown voltage. This is your IZ, and here you can show IL. So first of all, if circuit is to act as a regulator, the diode should be in breakdown, and to keep the diode in breakdown, current in the diode should be at least equal to knee current. Okay, current in the diode should be at least equal to knee current. तो अगर आप यहाँ पर IS लिखते हैं, let me just write here, for proper operation current IS should be greater than or equal to IZ minimum plus IL. Okay, current in the diode should be at least equal to IZ minimum. At the same time, some current should flow into the load also. Okay, and how much will be load current here? अगर आप load current find करते हैं यहाँ पर, it will be 8 volt divided by 1K. It is like 8 milliampere. For proper operation of the circuit, that current IS should be at least equal to IZ minimum plus IL. Okay, IZ minimum हमें पता है 2 milliampere and IL is 8 milliampere. So it will become IS greater than or equal to 10 milliampere. It will become IS more than or equal to 2 plus 8 milliampere. फिर आप IS की प्लेस में लिख दो VS minus VZ divided by RS. VS minus VZ divided by RS more than or equal to 10 milliampere. and if you rearrange it, it will become Rs less than or equal to Vs minus Vz divided by 10 milliampere. Rs less than or equal to this much. अब आप यहाँ पर Vs की वैल्यू पुट करो बेटा. Vs varies from 12 volt to 18 volt. If I take Vs 12 volt, then I will be getting Rs less than or equal to 12 minus 8 divided by 10 milliampere. It will give me Rs less than or equal to 4 divided by 10 milli. It will be like 400 ohms. And if you consider Vs 18 volt, then I will get Rs less than or equal to 18 minus 8 divided by 10 milli. I will be getting Rs less than or equal to 1000 ohm. Here supply is changing from 12 to 18. So by considering Vs as 12, Vs as 18, I have calculated Rs. Now use mathematics. Rs less than 400 ohm and Rs less than 1000 ohm. So what should be the correct Rs? From here I will get Rs should be less than or equal to 400 ohm. Okay, it is a less than inequality, and you know very well, when there is a less than inequality, we should select smaller of the two values. Okay, when there is a less than inequality, we should select smaller of the two values. So in this question, Rs should be less than or equal to 400 ohms. So we can take Rs equal to 400 ohm. That will be a correct value. Rs equal to 400 ohm. So in this way, if you look at the options, option A will be incorrect. Option A को आप कह सकते हैं false. Option B will be correct. Rs 400 ohm. Then we remain with one more option. Option D is already correct. We now think about option C. Minimum power rating of the diode. Now minimum power rating of the diode is nothing but maximum power dissipation in the diode. Whenever question comes about power rating, you should calculate maximum power dissipation. इस चीज को आप याद रखिए. पावर रेटिंग या मिनिमम पावर रेटिंग, वो कुछ भी पूछें, whether they ask you minimum power rating or power rating, it is always equal to maximum power dissipation. तो हम पहले यहां पर maximum IS फाइंड कर लेते हैं. IS max, let us calculate IS max. IS max equal to maximum supply minus Vz divided by Rs. Maximum supply 18 volt है and Vz 8 volt divided by 400 ohms. Okay, तो आप यहां से IS max फाइंड कर लो बेटा. 10 divided by 400, it is 25 milliampere. 25 milliampere. Okay, and when IS is maximum, Zener current also becomes maximum. Load current is constant here. Load current will remain 8 milliampere only. So when IS becomes maximum, IZ will be maximum. तो अगर आप यहाँ पर KCL अप्लाई करते हैं, then IS max is equal to IZ max plus IL. Okay, IL is constant here. When IS becomes maximum, Zener current will become maximum. तो आप यहाँ से IZ max फाइंड कर लो. IZ max is equal to, okay, it will be IS max minus IL. IS max minus IL. IS max is 25 milliampere and IL 8 milliampere. It will become 17 milliampere. फिर हम maximum power dissipation फाइंड कर लेते हैं. PZ max, it will be Vz into IZ max. Vz into IZ max. Vz 8 volt and IZ max 17 milliampere. It will become 136 milliwatt. This maximum power dissipation will be called power rating. Okay, whether they ask you minimum power rating or they ask you power rating, it is always equal to maximum power dissipation. So how much is maximum power dissipation here? 136 milliwatt. So in this way, option C is also correct. So in this multiple select question, 3 options are correct. And what are the correct options? B, C and D. Option A is false, whereas other 3 options B, C, D, they are correct. So this was your MSQ. Last year they included MSQ, right? But they did not ask MSQ in the actual exam, GATE 2021. They did not ask any MSQ, but there is a possibility this year they may ask some multiple select question. So it may take a bit of time. MSQ may take a bit of time because you have to check all the options here. In MSQ, you will have to go through all the options. So this type of question may take a bit of time. So in the actual exam, you can solve MSQs in the end. That is what is my suggestion. पहले आप multiple choice questions और numerical answer type questions solve कर लो. MSQs you can deal with at the end. If it is a numerical type MSQ, it may take a bit of time. If it is theory based MSQ, उसको आप easily solve कर सकते हैं. It may take less time. But numerical type MSQ may take a bit of time. तो मेरा suggestion ये होगा कि MSQ को आप end में solve करो. In the beginning, you go through MCQs and numerical answer type questions. And I'm getting one doubt here. Ke Vamshi is asking, can we remove load? In this question, we cannot remove load because load has a fixed value here. In this question, load has a fixed value. This is like a regulator for given load resistance. तो यहाँ पर हम लोड को हटा नहीं सकते बेटा. वी शुड नॉट डिस्कनेक्ट RL हियर. जब आप मैक्सिमम पावर डिसिपेशन इन द डायोड फाइंड करेंगे, डोंट डिस्कनेक्ट RL because here RL has a fixed value. If RL is varying, such question also came in one of the previous GATE paper where RL was varying. Okay, if RL is varying and if maximum RL unknown, then you take RL as infinite, remove RL and solve. But here RL is not varying. It is not a variable load. It is a fixed load. This regulator has fixed load. So don't disconnect the load here. Okay, keep the load as it is. Consider supply as maximum. Calculate IS max, then get IZ max, then maximum power dissipation, and that will become power rating. I hope the doubt is clear. So these were some important questions from analog circuits, and I will stop the session here. This session was just to give you an idea that what are the important type of questions that you can expect in the GATE. So if you are revising analog, then please follow this sequence. First you revise op-amp, prepare op-amp thoroughly, then you prepare MOSFET, second thing is MOSFETs, then third thing is BJT circuits, and finally do diode circuits. These are 4 important areas. Start with op-amp, then MOSFET circuits, BJT circuits and diode circuits. So these 4 areas you should be thorough. Apart from this, there are other small topics in analog circuits like multi-stage amplifiers, feedback amplifiers, oscillators. Okay, from these topics prepare a summary and revise that summary. They can ask you question based on multi-stage amplifier, feedback amplifier and oscillator also. In oscillator, especially Wien bridge oscillator, that is also important circuit. So first revise your op-amp, MOSFET, BJT, diode circuits. After that you prepare a summary for oscillators, feedback amplifiers, multi-stage amplifiers, and even for 555 timer prepare a short summary. That summary you revise. So please follow this sequence, and analog will fetch you around 10 to 12 marks in the GATE paper. So don't neglect this subject. इसका अच्छे से revision करिए, revise your class notes, and in the time available solve previous GATE papers. This much you can do, and don't get distracted whether exam will be postponed or exam will be on time. Don't get distracted by such news. You keep your preparation on, beta. Don't let anything distract you from your preparation. Keep preparing. Whether GATE is conducted on time or it is delayed, doesn't matter. आप अपना preparation जारी रखिए Okay, prepare in the best possible way. Revision, this remaining days, around 10-12 days which are remaining, they are crucial. Revision plays an important role. Revision kariye, solve previous papers. So that's all from my side. I will conclude this session here. I convey my best wishes to all of you, and I hope that you all will do really well in the upcoming GATE paper. Okay, so that's all from my side. Thank you once again, beta, and best wishes once again. And I hope you all come out with flying colors in the upcoming exams, GATE as well as ESE. Thank you once again.